Welcome to the video, finishing up section P1. We're going to look at absolute values, we're going to look at ordering real numbers, and we're going to go into a little bit more about the properties for simplifying expressions, algebraic expressions. The easiest part of this section is definitely going to be the ordering real numbers. Listed you see less than or equal, greater than or equal. The symbols we used to express inequality to talk about the relative size of numbers. So when we're talking about the number line is basically kind of our visual cue here. When we go to the left, we have smaller numbers. To the right, that's where we have our bigger numbers. So if we're trying to decide which symbol to use, maybe check out our numbers here. Maybe we have negative 13, and here's 0, and we have positive 2 on our number line, and we're trying to decide negative 13 compared to 2. If we were going to order that, showing what order they're in, because negative 13 comes farther to the left, we're going to use the less than symbol. Optional, we could use the less than or equal, the key word there being or. It only has to fit one of those criteria. It could be less than or it could be equal. So if I was going to say something like negative 5 is less than or equal to negative 5, that would be true because I included that equal portion in there. So just a reminder as far as ordering goes. Our real application of this idea, and we're going to use a little bit of symbolism here to define absolute value, would be, sorry, I lost my train of thought. We're going to use those symbols, the less than, greater than symbols, to help us define absolute value. Absolute value, the word definition would be how far a number value is away from 0, distance from 0. And when we're talking about distance, you would never say, I live negative 5 miles away from school. You'd always say a positive number. So distance means a positive number. So a lot of people just think, okay, absolute value of negative 5 is positive 5. But that's not really enough to help us with certain situations. So when we're talking about absolute value, we're going to use our generic variable here. Absolute value of x has two different values. So let's say we're finding the absolute value of 7. Well, the absolute value of 7 is just 7. So absolute value of x is going to be two different cases. It's going to equal to just x, so equal to that number that's inside the absolute value. But what's our situation where that fits? It's only if our number is a positive number or is 0. So if it's a positive number or it's 0, we're going to keep that same number as our solution. What if it was that negative number, absolute value of negative 5 would be positive 5. So how else could we write that? Well, we could say we multiplied negative 5, that original x value, by a negative 1. So really we're saying it's negative x, it's multiply or change, switch the sign of that x if you have that value less than, sorry, not less than or equal, just less than 0. If it's a negative number, we don't want that answer to be negative. We want it to be a positive. So absolute value of negative 3, we say that fits in our second case. So it's equal to negative, and then our x value is negative 3, so it's actually equal to positive 3. You don't have to go through that thought process for most numbers, but when we get into a little bit more complicated situations, you're going to need to. So our quick examples for absolute value, I think you can take care of those pretty easily. Absolute value of 5, absolute value of negative 3, and absolute value of 0. But when we get to something a little bit more complicated, you have to do a little bit of thinking. So remember, our situation is the absolute value of x. It's either going to be x if you're dealing with positives or 0, and it's going to be negative x if you're dealing with negative numbers. If you don't believe it, try a quick example. Plug in a number for x into the absolute value and see what you come up with. But what we need to figure out is this square root of 3 minus 1, the absolute value, is it equal to square root of 3 minus 1? Are we saying this is x, so it's equal to the same exact thing? Or is it equal to negative x? Do I need to multiply square root of 3 minus 1 by negative 1? So we need to figure out square root of 3. Let's approximate that. If you use your calculator, you could grab that. But what's square root of 3 going to be? Well, it's definitely going to be more than 1 because the square root of 1 is 1. So this value is going to end up being a positive number. Square root of 3 is definitely bigger than 1. When we subtract 1 away, we're going to keep a positive number. So square root of 3 minus 1 is still going to equal square root of 3 minus 1 once we take the absolute value bars away. If I did something like absolute value of 2 minus pi, we're going to have, this says 2 minus a number close to 3.14, dot, 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 keeps going on and on forever. If we want that absolute value, this is going to be a negative value. So we're going to want to take the inner portion, the x value, and multiply that by negative 1. 2 minus pi times negative 1 becomes negative 2 plus pi. It's a little bit of absolute value work for you. Another application of absolute value, if we have a number line, so let's say I'm going to use the points 5 and negative 3. Absolute value can also be used to find the distance. It's pretty easy once you graph it to see the distance between 2 points being 8, but how else can we get that number? Distance can be calculated by taking your first number, subtracting the second number away, and taking that absolute value. So if we did the absolute value of negative 3 minus 5, we'd be saying the absolute value of negative 8, which is actually 8. So the distance can be calculated visually, can be calculated also with that equation. We're going to really quick run through some properties of real numbers, give you a simplification problem, and then move on from there. So some important properties you use all the time but may not necessarily remember the names of. Commutative property, I'm just going to give you some quick reminders. Commutative property, what word do you see in there? You see commute. And again, this is for addition and multiplication. Both of these properties are. Commutative property means you can move the terms. And you may want to move terms so it's a little bit more convenient to look at a problem. So maybe 2x plus 5y minus 3x. You'd really like to combine those x's, but they're not right next to each other. You can move them because you're dealing with addition or addition of a negative, if you want to change subtraction to that. So you can move the order that way. Associative means you can group how you want. So if I have 2 times 3 times 5, maybe I feel more comfortable grouping the 3 and the 5 together and saying, okay, 2 times 15 is 30 instead of doing 2 times 3 and then multiplying that by 5. So associative, associate. Who do you group yourself with? How do you group the numbers? Distributive property, you should be well aware of. Multiplication outside of a parentheses with addition or subtraction in it. Just telling you can multiply that number by both terms or all terms inside. So 2 times 4 plus 2 times x is 8 plus 2x, something you've been doing since Algebra 1. Just real quick, properties of negatives, just to throw that out there. Just like when we consider a negative times a negative as a positive, just a little notation for you. If we're taking a negative sign outside of a parentheses, it's kind of like we're distributing negative 1 into those parentheses. So we're saying a negative times a negative. If I have some number a in there, this is going to be equal to a positive number. This is just a review of the vocab from the last video. Terms, coefficient, like terms, just some different words you need to be aware of. Just a reminder, this is the exact same setup you had, but terms are segregated by addition, subtraction signs. You have 4 terms here. Like terms have to have the exact same variables. So these are words that are going to be important, that are important to you. You've done a lot of work with simplifying expressions before, so we aren't going to go through step by step the simplification, but what are the big things to remember? Work from parentheses to simplify. Before we combine like terms, we always need to get rid of all of the parentheses. You want to work from the inside to the outside. So let's say this was in another set of brackets. This is the key piece that you'd want to take care of first. We'll always work with your parentheses first. So we have a minus sign outside of parentheses that needs to be distributed, and we have a -4 that needs to be distributed. Hopefully you're working along with me here. You can start to check your work. Negative times 7x would be -7x. And then we have a negative sign times a positive 6y. So we'd be at -6y. In the second group here, we're going to distribute the whole number here, this -4. So we'd have -4 times 3 is 12x. And -4 times positive 2y would be -8y. Here's where that the associative and commutative properties come into play. We'd really like to combine like terms. So if I put a box around my x terms, I'd really like to combine those. I could move those together and combine them into -19x. And then I also have these y terms that I'd really like to group together. -6y, -8y would give you -14y. So like terms, grouping, distributive property all come into play when we are simplifying equations. Your problem to complete that we're going to go over in the morning, this is the one I want you to work on, has some different terms, but notice x squareds are like terms and x's are like terms. So it has to be the variable matches identically. We'll go over this problem in the morning. Have a wonderful evening.